Sum number 10. Find the area of a rhombus if its vertices are 3, 0, 4, 5, minus 1, 4, and minus 2, minus 1 taken in orders. So we know that to find the area of a rhombus, and the formula equals to half the product of its diagonal. So now here you'll have to first know the diagonal AC and diagonal BD. So let's have a look at the figure that now we have got a rhombus, a polygon made up of 4 line segments where all the sides are equal. So you can name it A, B, C, and D. Now to find out the area of this polygon, or it is a rhombus, so we know that here the area of a rhombus equals to half the product of its diagonal. So that means here diagonal AC value we need and that of diagonal BD. So here consider a diagonal AC first. So first you can take the given points here. So these are the vertices of a rhombus. To find the area, I need a diagonal AC is also known by distance AC. Now apply the formula here that is known by the diagonal AC is given by the distance formula. So you'll have to flash back a formula. So distance formula equals to, yes, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. After that here you'll have to substitute the value of x and y. So you'll have to focus on A and C. So this will be our x1, y1. This will be x2, y2. So you'll have to start from point C. So here take the value of x minus 1 minus now x value, that is we have here 3 the whole square, plus similarly start from point C, y2 value we have here 4 minus y1, that is 0 the whole square, which is also equals to square root of minus or plus, and the sum is 4 but sign still negative the whole square, plus 4 minus 0 equals to only 4 the whole square, which is also equals to root over 4 square equals to 16 even power, so it will give a positive sign, again plus 4 square which is 16, and the sum of these two gives here a 32. Since we know that 32 is not a perfect square, now we need to break 32 into product of its prime factor. So divisible by 2 into 1, 1 in hand 6, again take 2 table, 2 8 times, again take 2 4 times, again take 2 2 times, which is equals to, we have here 2 into 2 into 2 into 2 into 2, so 1 2 3 4 5. So now we can see whether they can form a pair or not. So from this pair we take only 2, again from this pair take again one more 2. Now here we can see the prime number 2 left ungrouped or unpaired, so you'll have to keep within the root over, which is equals to 2 2's are 4 root 2 units. That is how I've got a diagonal AC. Again we need to find a diagonal, that is BD, which is also known by distance BD. Now take the formula here, diagonal BD is given by the distance formula root over. Now the formula you can take here x2 minus x1 the whole square plus again here y2 minus here y1 the whole square equals to, now we can see here the coordinates. Now BD, that means this will be x1 y1 x2 y2, so x2 minus 2 x1 4, so we can substitute here x2 minus 1, no that is minus 2 minus x1 we have there, that is a 4. After that the whole square plus, let's have a look the y value. So y2 value minus 1, y1 5. So we can substitute here y2 value minus 1 minus y1 value, which is we have 5 the whole square. That will give here root over minus minus or plus, so 6, but sign minus the whole square. Again here plus, minus minus or plus, which is equals to 6, but sign minus the whole square, which is equals to, now 6 square will give here 36, again 6 square 36, the power even, so it will give a positive, which is equals to 36 plus 36 equals to 72, and we know that 72 is not a perfect square. So what you'll have to do now, you'll have to break 72 into product of its prime factors. So 72 is divisible by 2, so take 2 into 3, 6, 1 in and 2 into 6. We know that 36 is a perfect square of 6, so that can be taken here, which is equals to 6 into 6 into 2. Now 6 is a pair, so it will be out from the square root. Now we can see here 2 left unpaired, so root of 2 units. But we need the area of a rhombus. To find out the area of a rhombus, now we can apply the formula. We know that here area of a rhombus is given by the formula, which is equals to half into product of its diagonals. Product of its diagonals. Now you can substitute here half into, so diagonal AC times of diagonal BD. We already proved above here, so half into AC we have got the value 4 root 2 times of BD, just now we have got 6 root 2, which is equals to, now here half into 4 into 6 into, now we know that root 2 into root 2, which is equals to 2. So now here taking root 2 into root 2, 2. So 2 we can cut here, so remaining 4 6 are 24, so the unit will be square units.